Hello viewers, this is Manas welcoming you to the series You the Oracle Expert, your one-stop shop to learn and practice Oracle database administration and Unix with hands-on experiments using Oracle VirtualBox virtual machines. Build your knowledge base, confidence, and make your way to be an expert Oracle DBA. In today's tutorial, we are going to learn about metric extensions in Oracle Enterprise Manager and how we can use a metric extension to trap and alert on long-running SQL statements. First, let's understand what is a metric extension in OEM. A metric extension is an extension to OEM's capacity to collect additional metric data on its targets. We will take one of our target databases as candidate database for this metric extension. From the list of target, I will go to this target called catdb, that is nothing but the repository database for this OEM system. Once you are in the database targets homepage, to see what metric data is collected by OEM by default on this target, we can navigate to Oracle Database, Monitoring, Metric and Collection Settings. In this page, we will be able to see a lot of different types of metrics are collected by OEM by default, like alert.log related metrics, dump area uses, incidents, recovery area uses, tablespace uses, etc. But if you find that a particular metric that you are interested in is not collected by OEM by default, then that's the right place where you will need to create a metric extension. For example, here you won't see any metric collected for long-running SQL statements on this database. So in this case, we can create one metric extension to collect data on long-running or bad SQL statements. Based on the values of the data collected, the incident rule set will send warning or critical alerts to the DBAs upon certain thresholds are met, and the DBA can then take appropriate action. We as DBAs already know about the impact of long-running and bad SQL statements in the database. They may come from applications and user who has direct access to the database, but whatever may be the source, a SQL statement deployed without a proper performance analysis is always a concern for the DBAs, because it may exhaust your temp table space, consume more memory causing high paging in the server, or even burn your CPU. You as a DBA should not be in dark about what's happening in your database and should have the capacity to notify a user or the application owner almost immediately about anything it has done that had a negative impact on the database performance. Today we will accomplish this by creating a metric extension in OEM. There are different types of metric extension that you can create, like SQL script-based metric extension, OS script-based metric extension, or SQL-based metric extension, etc. In this case, we will create a SQL-based metric extension, so we have to write the proper SQL statement that returns the right metric data, which we can then compare against the thresholds we set for appropriate alerts. For the SQL statement, I'll simply connect to our target database using Toad and as sysuser, and paste the SQL statement that I have already developed. You will be able to download this SQL from the text document in my Google Drive, for which I have given the link in the description of this video below. I will simply explain how this SQL statement is working here and what fields are getting selected. This is a select statement that is selecting the SID, serial number, username, OS user, program, machine, SQL ID, last call elapsed time, or last call ET, divided by 60 to get the results in minutes, which is more meaningful for us. Then this is the view that we are using, that is v$session, and the filters used here are status equal to active, because we are not considering the inactive sessions. Username is not null. There are certain sessions or internal sessions established by Oracle where there will not be any username associated, and we will be excluding those sessions. And the type of the session should not be background, because we are considering only user sessions. And the username not in sys, because The sys user is responsible for running backups or statistics collection jobs, etc., which are supposed to be running longer. And so that we can avoid getting false alarms on long running sessions or SQL statements, we have to exclude the sys user. Then last call elapsed time divided by 60. This number is in minutes, and we have to put the appropriate number here to get the proper alerts. So I'm putting here 10 minutes as our limit to get an alert. You can change it as per your requirement. You can decrease it to 5 minutes or increase it to 15 minutes or even 20 minutes. And this order by last call elapsed time is actually not needed. We'll remove it later on. This is just for the testing purpose. And we will see if there is any session selected here. There is no selected session here. It means there is no sessions currently running for longer than 10 minutes. Now we'll modify this SQL statement and lower this limit to something like 0.1 minute and see if something is getting returned. Yes, this time it is returning some rows, and those are from sysman user. Because this is an OEM repository database, so sysman is the administrative user which is supposed to be running many SQL statements internally, and those sessions are getting reflected here. Now we can say that our SQL statement is working. Now we have to modify this SQL statement so it returns only one single row with one single column or value, because the metric extension we are designing is going to accept only one single value upon which it will create the alert. Because we can see that there are multiple rows are returned, and we are primarily interested on the session which is running for the longest amount of time. So this is the top one, and that's the reason I put the order by clause there in descending order. So now we have to modify the SQL statement, and the modified version of the SQL statement I have already developed, and I'm just pasting it here, and I'll explain what it is doing. So it has a subquery, and the subquery is nothing but the initial query that we designed, and with an additional column that is the hierarchical function row number. So this row number will assign rows as per the descending order of the elapsed time, and based on the row number we will select only the topmost one, the record with the row number 1. So this subquery is giving us a result like this. There's an additional column rn 1 2 3, and the 1 is assigned to the topmost line, which is representing the session running for the longest amount of time. And from this subquery we are again selecting the relevant information, and that information is given to us in one single value. If we run it, we see that it's giving us only one column that has everything we need to create the alert. So what it is doing, there is a case structure, and this case structure is giving us this keyword that is critical or warning based on how long this is running. Say if it is running for more than 0.1 minute, then it is critical, else it is warning. So these limits we will adjust later on. For just testing purpose, I am putting this 0.1 there. Now the second thing that is concatenated with this keyword is the session information, that is the session within bracket the SID and serial, then some user information like the username slash the OS user @ the machine from where this session is established, then some program information like what program is running that SQL statement and the SQL ID itself, and at the end we are concatenating the elapsed minutes, which is saying how many minutes that SQL statement has been running for. And this entire column is given an alias as details. So this is the column that we are getting. This is one single value we are getting from the SQL statement, and we are all set for putting this SQL statement in the metric extension that we are going to create. Again, you will be able to copy this SQL query from the text document in my Google Drive. Now we'll copy this SQL query to our OEM metric extension. We logged into our OEM system using sysman user. Go to Enterprise, Monitoring, Metric Extensions. click on the create button, metric extension, and the target type on which this metric extension will be deployed is of type database instance. So we'll select the database instance type here. Name of the metric extension will be long running SQL check. Display name will be the same. It will be a SQL based metric extension, ME to check long running SQLs. This is the description. Data collection will be enabled. Data upload will be yes. Use metric data for alerting and historical trending. Upload interval 1 collection. Frequency. So this frequency we have to set carefully here. If we are trying to catch the SQL statements running over 10 minutes, then ideally the repeat interval should also be matching with that time limit. So let's put it 10 minutes here, then click next. Here we'll paste the SQL statement that we developed and copy it from our Toad session, and we have to adjust a few things here. For example, here the time limit will be 10 minutes and anything running over 15 minutes will be critical and rest of the things will be in warning level. Means this SQL statement will catch the sessions which are running SQL statements for the last 10 or more minutes, and if it has crossed 15 minutes then it will be considered as critical, otherwise it will be as warning. So from 10 to 15 it will be considered as warning. The moment it crosses the 15 minutes it will be considered as critical. Then click next. Then we have to add a new metric column here. The metric column is the field that is going to accept the value returned by the SQL statement. So as we designed our SQL statement that is going to return one single value of the type text, we have to define the properties of this column here. So let's put the name of the metric column as long SQL. Display name will be the same, and the type will be string. There will be no unit here, and the transient will be false. Comparison operator will be contains, and when there is a warning keyword in the return value it will be considered as a warning alert, and when there is a critical word there it will be considered as critical. As you remember that we are designing our SQL statement to return one single value, and that value contains one string keyword, either warning or critical. Manually clearable alert will be false. Number of occurrences before alert will be 1. Then we have to put one string value in this box which will be actually our alert message. So we will put like long running SQLs detected dash the value that will be returned by the SQL statement and assigned to this long SQL. So that value will be displayed in the message after this dash, and the clear message will be like, suppose the SQL statement is not able to extract any long running sessions. It means there is no long running sessions running, or the one which was already running has been cancelled or it ended. In that case we'll put like long running SQL cleared, then click OK. Click next, and it will use the default monitoring credentials. Click next. Now we have to test this metric extension against one of the target databases, just as a final step that everything is working. So we'll add one target database. let's take our catalog database, that is the OEM repository database itself. Select and then run a test. So it has not returned anything. For the metric extension to be able to return something, a session must be running a SQL statement for the last 10 minutes or more. So in this testing, we will not be able to find anything. If you want to get a real alert sent by this metric extension, then we have to temporarily modify the SQL statement again so that it catches some sessions. So we can do that by again going back, and in this SQL statement we'll make a small modification, and instead of 10 minutes we'll put like 0.5 minute here, and adjust the critical and warning thresholds here. If it is running for more than 1 minute, then it will be considered as critical, otherwise it will be considered as warning. So that way we don't have to wait for a very long time like 10 minutes or 15 minutes to test this metric extension. We will click next, next again, click next, and let's run the test again. Yes, it has got some warning and also the details here. Warning, session with SID 98, serial number 41617, and the user sysman /Oracle, that is the OS user in this server, admin server.manoj.home, from the program OMS, that is our OEM system, with the SQL query, and this is running for 0.9 minutes. So we have to make a small adjustment here because we don't want these many decimal places. So let's go back and round this value so that it returns only whole numbers. So all I did was putting this round function over this last call elapsed time divided by 60, and also we will adjust the time limits and the thresholds here so that we can deploy the final version. So again it will be 10 minutes, and anything running over 15 minutes will be considered as critical, otherwise between 10 to 15 it will be considered as warning. Click next, next, next. We don't have to test it again because we already tested, and we'll click next and finish. Now to be able to deploy this metric extension on actual database targets, we have to save it as a deployable draft. To do that, we'll go to this action menu and click on save as deployable draft. Again, to make this metric extension usable by other administrators of this OEM system, we have to publish this metric extension, and this has been published now. Now we will actually deploy this on our database target. So click on deploy to targets button here, click on the add button, then select the targets on which you want to deploy this metric extension. So in your organization there may be hundreds and thousands of different databases for which you want to monitor the long-running SQL statements, and you can select those from this list. In this test case, we are selecting only one database that is currently up, and that is our OEM repository database itself. So I selected this and pressed the select button. Now this metric extension is going to be deployed on only one target database. Click submit, refresh the page, and it's gone. It means the metric extension has been successfully deployed. Now to test a real case of detecting a long-running SQL statement and sending an alert, we will actually run something which will run longer than 10 minutes. We'll see if an alert is generated, and we get an email notification. Again, sending an alert is actually done by the incident rule set that is defined under this setup incident rule sets, and that is altogether a different chapter which I will cover in a different tutorial. For now, I assume that your incident rule set has been already defined and the appropriate emails for receiving the critical and warning alerts have been already set there. So now I will establish another session and will run one PL SQL block, and I'll make it to run longer than 10 minutes so that this metric extension actually detects the long running session and the SQL statement and sends an alert. Using a command prompt, I will connect to the target database using system user, and I will run a simple PL SQL block using execute command dbms lock dot, I'll call the sleep function there with a parameter of 1200 seconds. So whatever you put here is actually seconds, so 1200 seconds means actually 20 minutes, and we will run this block. So it will run for the next 20 minutes. Now we can go to our Toad session where we were initially developing the query to identify the long running sessions and see if something is detected, because this PL SQL block is currently running. And we can see that one session with the username system and the OS user Manoj using the program SQL Plus from the machine, that is my host machine from where I am running this command prompt, is running a SQL with this ID for the last 0.9 minutes. Let's round it, and it is running for the last 2 minutes. We are yet to reach our threshold when the metric extension will actually trigger the alert. Now it has just crossed 10 minutes. We should be able to see one incident in OEM. In the target database's homepage, we'll go under Oracle Database, Monitoring, Incident Manager, and we can see that one critical incident has been created. Let's click on this line to get more details, and if we go to Events, click on the actual event, and we can see what actions have been performed. Long running SQL detected critical from this session, user this one, the server name, program, and the SQL ID. How many minutes it's running? It's for 20 minutes, and an email has been sent to this email ID, and you can see that one email has been received. Click on this, and it's coming from this host. All the details required by the DBA to take action is mentioned here, that this is for this particular target database. Long running SQL detected critical session, this one, user system OS user Manoj @ the server name, program SQL Plus, SQL ID is also mentioned, and it has been running for 20 minutes. Now the DBA can either go and kill this session or notify this user using his OS user, because this OS user is usually an Active Directory authenticated user. So the DBA will be able to find out who is actually running this SQL statement. One thing I would like to mention here is we did not receive a warning alert as expected, because for this target database, the metric extension to detect long running SQL is running for every 10 minutes. So the first time it ran, the condition to cross the 10-minute was not yet met. So that's the reason it did not send one warning alert. But after 10 minutes, when for the second time this metric extension was running, then the session has already crossed the condition for a critical alert. So that's the reason we did not receive a warning alert, and instead we received one critical alert. So now we can go to our SQL Plus session, because I made it to run for only 20 minutes and it has already crossed 20 minutes, so the session is gone, and we can go to our SQL Plus session and we can see that the PL SQL procedure successfully completed. So we should also receive a corresponding clear alert. To see if we have received a clear alert, we'll go to Incident Manager again and we'll refresh this page. Incident is still there. The reason is because the metric extension will take another 10 minutes to run, because it is scheduled to run every 10 minutes. So it will give the clear alert only after 10 minutes of its previous run. So if we don't want to wait for another 10 minutes, all we can do is to select one option here, that is reevaluate alert. If we click that, then the incidents will be reevaluated, and we can see that the latest status for the event is clear. Click OK and refresh this page, and the incident is gone. So we should also receive one clear alert. Yes, we see that in our inbox there is a clear alert. So EM event clear. For this target database, alert for long SQL is cleared. So this is how we can use a metric extension to send warning or critical alerts to the DBAs upon detecting such SQL statements based on the threshold minutes we set. So in today's tutorial, we learned about metric extensions in Oracle Enterprise Manager and how to use a metric extension to trap an alert on long-running SQLs. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.